Hello, everybody. Hi, it's Charlie here. Wow. First of all, just want to say the work you're turning in is phenomenal. We know it's pretty tricky right now in the world, and it's a lot going on, but you are turning in incredibly creative and compelling work. And the work that you're doing since we launched our Change a Life campaign is nothing short of awe-inspiring, quite honestly. We've been talking about it behind the scenes with Misha and everybody here at GISH HQ. I just wanted to update you. In less than 24 hours, you have already gotten 49% of the goal of $100,000 for Ukrainians with disabilities and LGBTQIA plus Ukrainians. You're doing it. So please keep it up. These marginalized groups in Ukraine and these hotspots need your help. And they're being targeted. And for a number of different reasons, they are in need of a special kind of assistance, especially given how they're being targeted and the needs that are present. So you are doing tangible good. So thank you very much. We've got an amazing panel today. If you've ever had questions about the universe, as I do all the time, like why is this way, or feel free to use the Q&A. But we have more universe of fun coming the entire week. That's the cheesiest thing I've ever said in my life. We've got random acts, 1,000 acts of kindness. That item is very important to Misha and us. You can apply to provide an act of kindness and be funded for that act of kindness. So if it's giving someone flowers to brighten their day, or doing school supplies for a teacher in your life, you can apply for that $50 act of kindness and they will help fund you doing good in the world. They've earmarked $50,000 to do this. So go on and use the application for your team and then submit it, but also just know that it's there for you Gishers to do good in your own communities. We've got more items coming, more challenges, more fun, more surprises. So stay tuned for all of that. Make sure you're checking out the social media for GISH. I am super pumped today for Fraser here. Fraser is, well, he's an expert, and he is someone I actually really want to talk to because I feel like I don't understand the universe. Fraser is the publisher of Universe Today, a leading space and astronomy news website founded in 1999. And he's also co-host of Astronomy Cast, which is and co-creator of Guide to Space video series on YouTube. So you've been talking about and communicating and popularizing the exploration of space for almost your entire career, with a few exceptions to create some tech companies, as one does. Thank you so much for coming today, Fraser.
Thanks for having me. We
are in this very sort of spacey, space age hunt that we're doing here. So you're the right man for the job right now. Let's start. Can you?
If I can provide any information, I'm glad to help.
Awesome. Well, let's jump into it, because I think most people here, an initial touch point would be the big astronomy news of the summer, which is the first James Webb photos. What is the James Webb Telescope, and why does it matter so much?
Right. So the James Webb Space Telescope, as I'm sure you're all almost sick of hearing about, maybe not, is this new incredible space telescope that was launched by NASA back on Christmas. And it's been in development for 20 plus years. It's cost $10 billion. It's been described as the telescope that ate science, because all the budgets just went into building and launching the James Webb Space Telescope. And its job, it has sort of two main jobs. The one job is that because it's an infrared telescope, it's designed to look out as far back into the universe as really humanity can peer. Because all the galaxies that are around us today, they are in visible light. We can see them with our eyes. But over time, as these galaxies are shifting farther and farther away from us because of the Big Bang, the light from those galaxies is shifting into the red end of the spectrum. And so a galaxy that would have been visible today billions of years ago has now been shifted so that it's invisible to our eyes, but it's moved into the infrared realm of the spectrum. You could feel it with your hands. So if you know, imagine if you want to build a picture of what James Webb is seeing, you could like hook up a whole bunch of stoves and then you could feel them with your hands. And that would be the feeling of the warmth coming off of these galaxies as they've now shifted into the infrared. And so the plan was, let's build a telescope that can see in the infrared, that is primarily designed to see in that wavelength instead of the visible spectrum. And so now suddenly all of these galaxies that were invisible to the Hubble Space Telescope and other ground-based telescopes are now visible. They're now seen. And so James Webb can see these galaxies as they looked just hundreds of millions of years after the Big Bang. Really, when these galaxies, the building blocks that came together, formed the larger, more, the big spiral galaxies that we see today. And that's like the one main job. And then the second main job is that it has the ability to look into the atmospheres of exoplanets. So as you've got some star, it's got planeting around it. As that planet passes directly in front of the star, it obscures the light from the star and the star dims down in brightness a tiny little bit. And you can measure the atmosphere of the planet as it's passing. You're literally looking through the atmosphere of the planet as it passes in front of that star. And then astronomers can make measurements of that atmosphere. And so with the new pictures that I'm sure everyone's seen from Webb, we got a chance to see both these galaxies forming at the dawn of time, but also really detailed information about the atmosphere of one fairly famous exoplanet where they actually detected water vapor in the atmosphere. And it also does a whole bunch of other stuff. It can view through gas and dust. It can see right to the heart of the Milky Way. It can see newly forming planetary systems, and it'll even be able to look around inside the solar system to look for cooler objects.
That's incredible. And the concept that we have evolved our science enough to be able to look not only through space, but also through time, is such a strange phenomenon, I think, for a lot of us. Like, it's a little, I don't know, like almost unsteadying to think that we can be seeing light from back in time, and the correlation between those two things, obviously. But when it comes, there are a lot of space fans here and a lot of space exploration fans here. I'm definitely one. I always wanted to go to space camp when I was a kid. Didn't get to go. Still mad about it. Why are we, I think, to the people who don't get it, why are we dedicating so many resources to space exploration? What are we looking for? What are some of the ways that, scientists have sort of explored this universe? Why are we doing this? What are we doing?
Well, I mean, the basic part of this is that it's curiosity. When you think about the universe, most of the universe is not Earth, right? 99.99, however many nines you want to put afterward, is everything. And then a tiny little fraction of that is the Earth. And so it makes sense to have this basic curiosity about the universe as we have come to understand it. And I think, man, like for me, it's just about context. As you said, you stare at something that maybe you see the Andromeda galaxy, and that is actually, you're looking at the light that's been traveling for 2.5 million years to reach your eyes. And yet our one planet is just part of one galaxy that's part of one galaxy cluster. And it's galaxies as far as you can look. And when you see that, you just have questions. Where did they come from? How come there's so many? Why are they over there and not over there? And why? And then you wonder what's in them. I mean, planets, stars, and of course, are there other civilizations out there, alien species that someday we could meet? And we know so little about that, essentially the entire universe. And we have this one little vantage point that we can try to explore. And that's why we do space exploration, is to push to other vantage points. It's a lot easier to explore Mars when you're on the surface of Mars. It's a lot easier to explore Saturn when you're orbiting around Saturn, when you're doing a flyby of Pluto. And I think it just comes down to curiosity. We just want to know more about this universe that we find ourselves in.
It's so, I mean, it's incredible and what that can do for you. Misha and Philip and Hillary and I went to JPL NASA once to see the helicopter before it was
Oh, amazing.
released. We got to go in this room and see where they test like the air flight, and they reduce the oxygen and they reduce some of the gravity elements to try to understand how it would take off and set down. And I think there's something so powerful about seeing that, getting that curiosity stoked and continuing to peer out into the universe in that way. And when we see that these photos from James Webb, we know there is a tremendous calculus and math to, we're just one thing and one vantage and one point of view and one sort of speck in this just sparkling universe. I think the question I have though is, what are some of the ways that scientists have theorized about how to explore the universe? You know, how are we going to do that?
Right. Well, I mean, it is tricky. It's very big. And to this point, our exploration of the universe has been largely listening, that we are either looking with telescopes, we are listening with radio waves. We're now even able to observe in gravitational waves, these ripples of space-time that come from giant objects crashing into each other. And so we're gaining more and more ways to observe the universe, but still we're stuck here on Earth and in low Earth orbit. And maybe we've gone to, as I said, Saturn and Jupiter. And so the future, in the far, far future, will probably have to shift to some way of traveling from star system to star system. And actually, this was an idea developed by John von Neumann. He was a very famous mathematician back in the 1940s, but he developed this idea of a von Neumann probe, a self-replicating robot, where you would send a robot, like a fancy 3D printer with a good rocket drive, and it would fly off to another star system, and then it would build copies of itself, and those robots would then fly off to other star systems, and they would build copies of themselves, and so on. And it's been predicted that if you can build a spacecraft capable of going about 10% the speed of light, you should be able to explore the entire Milky Way. So 100 to 400 billion stars in about 10 million years, which sounds like forever, but that's just a blink in the lifetime of the actual universe, which has been around for almost 14 billion years. And so we can imagine some far future, and it's not that long from now. I mean, we've already got 3D printers. There's actually 3D printers on board the International Space Station. We can print in different kinds of material, fabrics, metals, plastics, meat. And you can imagine, within the next few hundred years, we'll probably start to set off in search of other star systems, starting to try to explore the Milky Way, and then send messages back home, categorizing everything that we've seen out there. Because right now we just live in science fiction land. We imagine what these other star systems look like, what these other planets, what these other life form civilizations. We have no hard data, and it would be incredible for us to be able to do that.
That's so true. I mean, first of all, the idea of a self-replicating 3D printing robot getting some Mass Effect vibes. I'm a little worried about it, but I like what you're saying, because that's a good way to scale exponentially how we explore, and that's with something of this size. That's the only way we're really going to make a dent in that part of the universe. And if you have questions, by the way, please use the Q&A box. We'll try to get some questions at the end of this panel as well. I would love to talk. I mean, we've asked Gishers over the years to do quite a few astronomy themed items, this hunt and other hunts, including this one, building an origami version of a collapsible star shade, and maybe even design a functioning 100-meter version of that star shade or whatnot. I'd love to hear from your vantage, because you're speaking the science language. And science fiction has always been a really beautiful marriage between art and science. What do you think is the relationship between art and technology? What are some examples of art influencing science or science influencing art for you that you can share with us?
Well, I think the field of astrophotography is absolutely one of my favorites. I think you've got a not real picture behind you, but in many cases, a lot of the pictures that we all have come to really love of space, of galaxies, of star clusters, of nebulae, things like that, those are pictures that were taken either by a scientific instrument like the Hubble Space Telescope or James Webb, but as often as well by an amateur astronomer, someone who has their own telescope set up in their backyard, and they're taking these incredible pictures of space. And the process of building an image, the kind of image that you see, it's actually very complicated and very much relies more on art than on science. I mean, when you see a picture taken from the Hubble Space Telescope, for example, I mean, Hubble is opening up its aperture, it's taking a picture at a certain wavelength of light for a certain period of time. And then it's doing that for multiple filters on board the telescope. And then that's raw scientific data. And then an astronomer is going to look at that and go, okay, great, I got this image of a supernova, I got this data on where the star forming regions are, et cetera. But an artist can come along, take that same data, pull it into Photoshop and say, okay, this filter is red, this filter is blue, this filter is green, this image was taken for this long of an exposure, et cetera. And they can blend those three images together to form a full color image. And when you think about all those famous pictures, the pillars of creation, the new Carina Nebula, all of that, that is because someone took their artistic aesthetic sense and worked with that image to be able to create something that is in this case no longer scientifically useful. So these, when you look at the pillars of creation, a scientist can't use that image anymore, but we as the public, can appreciate the beauty and the art of what we're seeing. And I always feel like such a bummer because our eyes can't see that. People always ask me, if I could go and stand beside the pillars of creation, would I see that? And the answer is no, because because our meat cameras are throwing out the photons every 30 seconds. And so we're not able to perceive these objects. It takes this kind of a telescope, it takes this kind of instrument for us to be able to see things that are so beautiful. And then from the kinds of astrophotography that people are creating, that's helping to define new interesting science, because now we're able to perceive these things. You can look at a glance and go, oh, there's craters over there. Oh, there's star formation over here. And that can help define the actual technology. And so we're really fortunate, I think, in the world of astronomy that these things are so beautiful and also so scientifically useful to help understand the universe. It's a beautiful blend between the two.
That's such a great answer. That marriage between art and science is really it's also a testament, I think, human creativity. It's like we're trying to evolve our understanding, but also the way in which we communicate it, and that communication helps get people inspired. And then the science of it helps us more deeply understand something, and it's just like a never-ending cycle. Also, you can't say meet cameras to this group of people without them wondering if it's going to be a GISH item, Fraser. They're like, are we doing meet cameras? We don't have to do meet cameras, right? Please don't. You fell into that one. This is what we do.
I want to see. I think it's great. I'm behind it.
Well, listen, they're threatening me now. They're threatening me in the chat. I'm not. Listen, the item is coming. Let's take a couple of questions, and then you'll see what the item is. So Danielle asks, is it really feasible? Is it really feasible to think man will be able to live on another planet or in space at all someday? Or is this truly a pipe dream? As Charlie said, we are specks in the universe. Great, quoted.
I think that in the short term, it's not going to happen the way people are hoping. So I think a lot of us have this very near-term vision of a city on Mars with 1 million people. It's possible some rogue tech entrepreneur is planning such a thing. And Mars sucks. It's just the worst. Space sucks. The moon sucks. They're all terrible. And you've got constant radiation. You've got you've got wild temperature changes. And so I think for a lot of people who have this romantic notion that we're going to be living on Mars, like go spend a couple of years in Antarctica in a hole, see how you feel about that, and then remember that Mars is worse. And so I think in the short term, we're not going to see that kind of expansion out into the solar system. But our technology has a trend of making things trivial. And so who knows, in 200 years, 300 years, when our technology brings it up to the level, well, suddenly building a giant space station in space that you can control the temperature, the climate, the distance from the sun, you've got lots of energy that's flowing in, you've got lots of material to work on, you can rotate it at the speed that you like. It's an access point to other parts of the solar system. That stuff starts to make sense as well. So I think in the near term, no way. It's always going to be a couple of people on a space station on the edge of death. But in hundreds of years, I think, our technology will accomplish amazing things. Beyond the solar system, it's going to take a while because those journeys are just so vast. Even if you could travel at the speed of light, which you can't, you're looking at years to get to the nearest star system, decades to get to other star systems, thousands of years to cross the Milky Way. And so
the scope of it is just so, it's so intimidating, and it's so, I read sci-fi to get inspired a lot. And I also feel this like weird loneliness when I read that, because it's such a generational level thing to even get anywhere. And then by the time you travel at that speed, everything else is gone behind you that you knew. And like that is an intense concept for us to think about, especially when we're like struggling here on this planet and they're like, we can't get off. And there's plenty of movies and books like about that topic, whether it's Contact or otherwise. Like there's a pushback within us to stay where we are and just deal with what we know and deal with what we're dealing with and not look beyond that. But the survivability of our race in some ways depends on that wider scope,
But we are fortunate. We are fortunate to live in the best planet in the universe.
Oh, wow.
For us.
Yes.
When you think about it, we evolved to live on Earth. And so no matter where we go in this entire universe, any other planet, any other star system, it will be a pale shadow of the quality of Earth for us to live on. The only place where we'll be able to breathe the air, drink the water, be able to eat the food, for sure.
Yeah.
And so you could imagine going to other planets. You on Mars, and you're like, yeah, that is a big crater. That's impressive, right? Any way that you would enjoy going on a holiday. But to live day in, day out, you really appreciate being able to walk out your door and breathe. So I think that even if we may have to live vicariously through our self-replicating robots on other star systems, we will be able to still enjoy living in the best place in the universe.
I love that the takeaway from this panel thus far has been, for many people in the chat, Mars sucks. This is the best place in the universe for us. And then we put up a flag and go, yay. It's true. I'll take one more quick question here. So the Helen asks, the description of the new James Webb Telescope images of the Cartwheel Galaxy mentions a collision. What kind of collision and what happens when galaxies collide? Also, our 20-year-old son Matthew is a huge fan and is studying astrophysics in part because of you. Thank you.
Wow, that's amazing.
Yeah.
So the Milky Way today has, I mentioned earlier, 100 to 400 billion stars, and it has this giant, beautiful spiral formation. And yet we know the universe started almost 14 billion years ago as this diffuse cloud of gas. And so how did it get from there to here? And this is one of the big fundamental questions that astronomers are still trying to figure out. But the assumption is that in the beginning, the first stars formed, and then those first stars formed into galaxies, but very small dwarf galaxies with maybe a few million stars together. And then those small dwarf galaxies merged together into larger and larger objects. And in the beginning, when the universe was a lot more densely compacted together, these galaxies were smashing into each other all the time. But then as space has been expanding, becoming less dense over time, then these collisions happen more rarely. But yet with space telescopes and even ground telescopes, you can look out and you can see where these giant galaxies are still merging together, or they were merging together hundreds of millions of years ago when they're being seen in the telescope, because the light, it's very complicated. And we know that, in fact, this is the fate for the Milky Way. So Andromeda Galaxy is one of the few galaxies that's actually moving in our direction. And in the next 5 billion years or so, the Milky Way and Andromeda, which are going to merge, and they're the two largest galaxies in this area, and form this enormous spherical galaxy, which I like to call Milkdromeda, in the next few billion years. And then this whole thing will settle down. A few more galaxies will join us, and then that'll be it. And so we see these collisions, which tells the story of how galaxies came together.
Again, Fraser, you can't just say stuff like Milkdromeda and then not have Gishers assuming that this is what we're going to be doing.
Well, this is important.
Okay, all right. Milkdromeda, I ship it as well.
The Milkdromeda is very, very important, because other people have other names for this merger of Andromeda and the Milky Way, and they're really like objectively worse.
Okay, yeah.
And so I think it's really important that at least I can plant that flag and go that this is the definitive name that I really want us to use. And maybe in 5 to 7 billion years, that name will stick.
And Dilmy Way. No, it's not going to work. You're right. Absolutely. Well, meat cameras and Milkdromeda. Let's get to, well, first of all, I want to make sure that we promote you because this community should be supporting you in the work that you're doing. Please, everybody, you can hear more about the latest astronomy news on the Universe Today podcast, The Guide to Space, available on Spotify and all major podcast platforms. You can find Fraser at F. Cain on Twitter and Instagram there. Universe Today, go find it, universetoday.com, etc. Please go follow and support the work that Fraser is doing and these platforms are doing. We need to focus on science and science education and a love of space exploration to, again, inspire us here on planet Earth, but also keep pushing the boundaries of what we know. Are you guys? Let's do the actual deliverable, which is not yet Milkdromeda or meat cameras. Fraser Cain described why space exploration is critical for the progress of humanity, but it's a big universe and we're going to need a lot of help. So it's time to get machines in on the creativity. Build a von Neumann probe, a self-replicating robot or device capable of making a new version of itself. Is a 3D printer bot printing a new 3D printer bot? Is it a knitting bot? Knitting another knitting bot? A dancer bot that makes its own backup dancer bots? Show us your most creative von Neumann probe. Be sure to show us that it can be turned off. We don't want a Reaper situation on our hands. I know. Post your videos on social media tagging FCain, Universe Today, and hashtag GISH. That is 62 points, y'all. Thank you so much. Fraser, and after this today, if anyone needs some therapy thinking about the suckiness of the universe or that planet Earth is being cruel to you, or just wants to hang out with a cool therapy gecko, we have Lyle the therapy gecko. He is an unlit licensed lizard psychologist who has a show, and he's going to help teach us a few things about lizard psychology. We've got a lot more in store for you, obviously. More days of fun coming up tomorrow. We have Laura Jack, who is a grief expert and compassion coach, a well-known author and speaker. It's going to be really powerful, so I would recommend definitely tuning in for that. If you liked this, you'll love that. And so much more to come. Fraser, thank you so much for your expertise and your time. Thank you for everything you're doing. We really appreciate it.
Happy to do it.
All right. Thanks,
Good luck,
everybody.
everyone. I can't wait. I want to watch your robots.